Hi, this is Asad Ijaz. I hope you all are doing well. So basically, this lecture is for educational ecosystem. So today I'm here to describe my portfolio work, which I have done last time. We started with the content. Our project is lottery number prediction system using Python and ChatGPT. First of all, if we search the packages we used in this project, so we use ChatGPT for that. Okay, so we open the Open AI ChatGPT. So first of all, we search it on it which type of packages are used in lottery prediction system. Okay, we can say which type of Python packages. You can type Python here. Now it will describe some packages like we use in our project. So I'll describe these packages one by one. So first of all, we introduce all those packages. We will check what they have done and what type of functions they have included in this project. So NumPy, Pandas, these two functions, and scikit-learn, TensorFlow, and Keras. These three packages are used in this project. Okay, so briefly we can discuss these packages. Pandas is basically the Python library which is used for like manipulating some data sets for data cleaning, data exploration, and manipulation of data. And the other package which is very commonly used in data science work, this is NumPy. And NumPy is mostly used for work like numerical data. If we apply some statistical work, like we apply some as we want some type of mean, medians, or modes of any data sets, or to find some standard deviation. So it means all type of mathematical and statistical work. So we used NumPy package, which is which is Python package to apply some statistical uh, formulas. So if you use Excel, so you see that in the top right corner we have some built-in functions. So those functions are specifically for to apply some methods on a specific rows or columns. So you will just select the column or row in your Excel sheet, and you will apply the function on the specific row or column. So your calculation will be applied. So at the end the number is calculated, or the standard deviation, or addition or subtraction, any kind of operation will be performed on that specific row or column. So in programming term, if we want to do that type of work, so we use Pandas. Pandas is basically sum up your data and collect your data and organized in an organized form. It's an or architecture. The architecture of Pandas is like rectangular data frames. Rectangular data frames are like we have searched what type of rectangular data, so we will find it. Rectangular data frames. Rectangular data are the staple of statistical and machine learning models. Rectangular data are multivariate cross-sectional data. Example note: time series or repeated measures, in which each column is a variable. Okay, so it is a concept. So you will find if you go in the depth of Pandas library, you will find more functions of it. So we just introduce it. So this is Pandas, and NumPy is also statistical library. Now the other package we used is scikit-learn. Scikit-learn is a library which implement the machine learning models and statistical models. And through scikit-learn we can implement various machine learning models for regression, classification, and clustering, and these are algorithms which are used for that. And keras is also another package that deals with some neural networks. Okay, so I hope you have you have a brief idea about those packages. So these are four technologies we used in our project, in our lottery prediction system project. Okay, so now we start our project with the environment. So if you have Visual Studio Code, you will easily apply those packages, and because it is easy to install these packages using pipe on your command line terminal. But if you want to compile your code line by line, so you it's better to do that work in Anaconda, Jupyter Notebook, or Google Colab. So I use both of them. So Jupyter Notebook is open source, you can find it, but you have to go to their official website. Jupyter Notebook, sorry about that, my internet is slow, so you have to bear with me. So there's the official Jupyter Notebook website. You have to download it. So I have already downloaded it. Anaconda. Where it is? Here it is. Anaconda 3. So you have to download the latest one. So after installing it, install Anaconda. You have the application installed in your system, Anaconda Navigator. So after that you will open your Anaconda terminal like that, and type Jupyter Notebook. So this command will open your notebook automatically. I'll describe the difference between VS Code and Jupyter. Basically, Jupyter is it includes some packages by default. You don't need to install it one by one. So this will, I mean, it takes lots of time, and I mean, your time is more important. So you have to install Jupyter, or the Google Colab is basically very important, because Google Colab is not running on your local system. Google Colab is working on cloud base. So the load is overall, I mean, your when you train your model, specifically when you have lots of data, so on your local machine, it takes, if you have lower RAM, and you don't have any SSD memory on your laptop or Windows PC or Mac or something. So it takes I mean, it takes more load, and your system will be heated, and in that work is not good, I mean, for your PC. So you have used to Google Colab, because it's cloud based, and it's on cloud. So you will easily train most of the data, and any kind of algorithm will be trained easily on Google Colab instead of using Jupyter. But I do some of the work on Jupyter Notebook. After that, I also tell you about Google Colab, and we do some of training part when we apply Keras library. So we do that work, that stuff on Google Colab. So I don't want my PC to be heat up, so that's why. Okay, so the for the without wasting any time, when we set up our environment, so it's like that. You will open a folder or create a new folder here. From the top right corner there is a scroll bar. You will find an folder, Python 3 IPY kernel. So if you click on IPY kernel in a specific folder when you create it, so you have kind of cells like that, and in these cells you will write your code step by step. So in each line you will find that if there is any kind of error it will tell you, or if there is no error it will clear you. Like if we type TensorFlow STF from TensorFlow, it's a machine learning library, STF. So you can see it will give us an error. But if we type import pandas SPD, um, so it will compile successfully. You can see that I don't install any pandas in it. I just install the Anaconda software, and it will automatically brings all those packages with that. So you will install it. After the installation and doing this work, so we have start our project work. So I to save my time I already have doing it, but we have done it. We will do it again. So I will start in other file. I created this file, and so first of all we import the pandas library. Here it is, and we briefly already described about what it is and what it will done. It is for, and it is for analyzing and cleaning your data and exploring the insights, which will be like and the visualizations. We see in some numerical data how it will be compiled using programming. So pandas is for that. So it will sum up your data in the data frame, and yeah, we have import this library. Now after that, numpy, the other package. Okay, we have also imported that package. Now it's time to run this cell. So after when we run each time, it will tell us now this specific cell is it runs 4 times, and it will show the number shown here, how how many times it will it is compiled. So if we compile it 5 times, so there is number return is 5. So okay, after that, now we have scikit-learn, which is for like algorithm work, like classification and clustering. So we have to import it. Now run this cell. It will show it is showing an error, but it's not an error, it's just a warning. So if there is error, we don't go, I mean we don't have any option to step up on other cell. So in case of any warning, we will easily step up in another cell. So after that, we have to prepare our data. So in this project, we are using some data of lotteries of past 2 weeks. So this is our data. Basically, in these brackets, we have the numbers of I mean 7 days. For each day we have a specific number like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So we have the separate numbers in the list. So how we will do it? Okay, we can see in the data preparation part, we comment out this cell data preparation. Okay, we have done with project and technologies introduction. Now you also have idea about setting the environment as well, and how to open it and how to install your package in it. If you want to install any kind of package, you have to do like pip install and the name of the package, name of package. Suppose if we are installing NumPy, we just type NumPy in front of pip install. So it's a command line for which is used for installing any type of package directly in your Anaconda. Okay, so we have now jumped to the data preparation part. So now you can see pd.dataframe basically is a function which comes from pandas library, and in this library we used numpy array for making and arranging this data in the matrix format. Okay, I will show you how it works. So after that we have the headings of the column as well, like we have 6 columns A B C D E F. So at the end of this we have introduced our columns in a list. So it will merge your columns and the rows in a proper format because it's data frame. We already define it what it will sum up your data in a proper format. Now we will run it, and now we have, if we have want to check what is in the df variable, basically it's a variable or a container which contains all your values. Now you can see these are our values. 2 weeks, 0 to 14 means 0 in the programming index. If we count 1 to 14, it in a programming it counts 0 to 13. So okay, 0 is also an integer in programming. Okay, now we have like the data frame here. If we want to print all data frame, you just type df, or if you want to print first 5 values, df dot head is a function. Head is a function of data frame. You can run it and it will show you the first 5 values. So we can see these are the list of like the heading names, and there is a lottery numbers which is specifically arranged in each row. Like there is in this row is here, and all the data is arranged in a proper format using this. So so after data preparation we have like normalization work. Okay, so after that we have data normalize, we have to normalize our data. So we have to type this on ChatGPT. So it will easily describe you what it will in this function is for. The standard scalar class is used for standardization of features, which means transferring the data such that it has zero mean and unit variance. It's like you will normalize your data in floating point values, and it will transform it, and it's easy to make your model accurate. So we have do this work. First of all, standard scalar function, we just put it in a variable scalar. Okay, so this line we type here. Okay, now run this cell. It will run. Okay, successfully. Now after that, you have scalar dot transform. Basically, transform is a function which will transform the scalar values uh, in a format. Okay, you have to, and you will put this in another variable called transformed dataset. Okay, transform dataset. Now we have transform dataset. So it will transform, so we can check how this looks like. Okay, you can check these are our previous values, and now we have the data in this format. So it means our data is near to normalized, not fully normalized. So after that, we have one other step. For that, we have to put this data in a proper data frame, and and we have another variable called transform data frame, df mean data frame. So we use data frame to set this data frame transform data set in a data frame. Okay, so we have to use this in this cell. It is running. Okay, it runs successfully. Now we have to check